So take down the problem. Given the waveform, x of t, plot, you have to plot 4 different types of waveforms. So first one is x of t into u of 1 minus t. Second one is you have to plot x of t into u of t minus u of t minus 1. Okay. Third one is you have to plot x of t into delta of t minus 3 by 2. Fourth one you have to plot is x of t into u of t minus 1. So you are given with x of t and you are asked to plot all these 4 waveforms. So let us see how our x of t looks. So this is your x of t. Okay, so this is instance 1, instance 2, this is your time scale t. So you have been given with x of t in this question and you have to plot 4 different types of waveforms. Okay, x of t into u of 1 minus t, this is first waveform which you have to plot. Then you have to plot x of t into u of t minus u of t minus 1. Then x of t into delta t minus 3 by 2 and x of t into u of t minus 1. Okay, given a waveform, so you have to plot the multiplications of these. Okay, so first one we'll try to plot the first waveform x of t into u of 1 minus t. Okay, so from the basics, what should we do first? So we shall see what is so first waveform we'll be plotting is x of t into u of 1 minus t. So what is the first thing you'll be doing? We have a multiplication function, correct? So we'll try to plot u of 1 minus t. Then we'll multiply that with x of t and we will see the resulting waveform. So first try to plot u of 1 minus t. How will you plot u of 1 minus t from the basics of shifting? From the law of precedence, we know that first we have to do shifting. You have to do u of t plus 1. Then you have to time reverse that. Okay, or you have to take the reflection or time reversal to get u of 1 minus t. Okay, so try doing that first. So we know that we have a continuous time unit step signal u of t. So it will start from 0 and it will go up to infinity with an amplitude of 1. Okay, then you have to plot u of t plus 1. Shifting, first is shifting from the law of precedence. So from where will it start? The signal u of t plus 1?
Minus 1.
What about others? From where it will start?
Minus 1, ma'am.
Minus 1.
Yes, so you have shifting with k positive. If k is positive, it is left shifting and the signal is occurring 1 second earlier. Okay, so you have a signal starting from minus 1 and it will go up to infinity with an amplitude of 1. Okay, this is u of t plus 1. So how will u of 1 minus t look?
From plus 1 it will start and it will go to minus infinity.
So taking time reversal of this, okay, whatever is there in the right will go to left, whatever is in the left will go to right. Okay, I'm folding this signal about vertical axis or y axis. So my signal will start from minus infinity and it will go up to plus 1 with an amplitude of 1. Got it, everyone? Understood? Got it, everyone? How to plot u of 1 minus t?
Yes, ma'am.
Now we have to multiply x of t and u of 1 minus t. These two.
Ma'am, can you scroll a little bit up?
This is a given question. Given the waveform x of t, you have to plot 4 different plots. First one is x of t into u of 1 minus t. Okay. So first we are trying to plot u of 1 minus t from the basics. We know first we have to do shifting to get u of t plus 1. Then to get this reflection, you have to take u of 1 minus t. Got it? Because t1 is positive, but t should be negative. So that you have to do reflection. If you do reflection, you will get this waveform. So now try to multiply these two, x of t and u of 1 minus t. So what do you get if you multiply that? This is u of 1 minus t and this is x of t. We know that u of 1 minus t extends from minus infinity to 1, whereas x of t extends from minus 1 to 2.
Yes, ma'am.
So,
Ma'am, basically we are doing the reverse, right? So if it is 1 minus t, we are taking it from minus infinity to positive 1.
no, don't think like that. We have u of t. It's a unit step starting from 0 up to infinity.
Yes,
To get
ma'am.
this, what you have to do? U of 1 minus t. Don't assume things, just do it practically. Okay?
Yes, ma'am.
So you have to get this function, you have to do shifting first.
Yes,
That is
ma'am. We have to
u of t plus 1. Then time reverse that to get 1 minus t.
Okay.
Now we have to multiply these two signals, u of 1 minus t and x of t. That is the first one they have asked you
Yes.
to plot this x of t into u of 1 minus t. So how will you do that? We have multiplication of x of t with u of 1 minus t. Okay. So here between what range of values of t are multiplying x of t and u of 1 minus t? What is the overlapping space between these two?
-1 to 1 only it will exist, ma'am.
Yes, the overlapping space is from -1 up to +1 only. Okay. So the overlapping space is -1 to +1, which will give you the perfect waveform. So whatever is the waveform between -1 to +1, that will be reproduced when you multiply x of t with u of 1 minus t. So we shall see that. So you have x of t into u of 1 minus t. So how will your waveform look? This is 1 here. Okay, from minus infinity to 1, it is amplitude is 1. 1 multiplied with anything will be 1 only. So your waveform will be from -1 to 1, it will be like this. Then it will be like this from 0 to 1. Got it, everyone?
Yes, ma'am.
Understood, everyone? Here, see here. In u of 1 minus t, you have a signal from minus infinity to 1. Here and all you have zeros. The amplitude is 0. So 0 multiplied with this 2 is 0 only. Here it is 2. Okay. So you will get the overlapping space, whatever is there between x of t and u of 1 minus t. Got it, everyone? This is the first waveform. Understood? You have any doubts?
But -1 also it will be 1 on an amplitude.
Where?
But -1.
-1? Here.
Amplitude will be 1.
Yeah, it is -1. See, in u of 1 minus t, the signal is existing from minus infinity to 1 with an amplitude 1. 1 multiplied with anything is 1 only. Correct? So we are trying to multiply this amplitude with this amplitude. You will get back this signal. Because in x of t at -2 you have 0. 0 multiplied with 1 is 0 only. Got it? Check to the left of x of t and to the right of x of t also. And what you have here? U of 1 minus t. Check to the right of u of 1 minus t. The signal is existing from minus infinity to 1 with an amplitude 1. Okay, to the right of u of 1 minus t, that is near instant 2, the signal is 0. So from here to here we will not get anything. Okay.
But 1 amplitude is 2. So 2 into 1 is 2.
No, the signal is existing only this much, right?
Yes, ma'am. At 1 amplitude is 2.
The signal is, you're multiplying this with this. At 1 it is 1, it's going to 2. If you
Ma'am,
overlap
at
these
1
two,
is the amplitude 1 or 2, ma'am. X of t.
it is 1 going to 2. But if you multiply
We
this
should take
one
1,
with
ma'am.
this, you'll get 1 only, right? Check the overlapping space. You try to put this on this. This is the overlapping space, right?
Yes, ma'am. Yes.
So this will be the multiplication of x of t and u of 1 minus t. Okay, whatever is the overlapping space that you are reproducing here when you multiply x of t and u of 1 minus t. Got it?
Yes, ma'am.
So now we will try to plot the second waveform, what they have given. So second one is x of t into u of t minus u of t minus 1. Correct? So first we have to plot this u of t minus u of t minus 1. Understood everyone? First one. So this is the first one, x of t into u of 1 minus t. So second waveform is, which you have to plot, it is x of t into u of t minus u of t minus 1, correct? Now try to plot this one first. We know that unit step signal u of t extends from 0 up to infinity, up to t is equal to infinity with an amplitude 1. And from where to where will u of t minus 1 exist?
Starts from +1 and it will go to infinity, ma'am.
Correct, everyone? K is negative here, okay? The k here is negative, so it is right shifting. That means our signal is occurring 1 second late, okay? It will start from 1 and it will go up to infinity. This is the signal u of t minus 1, okay? So if you subtract these two signals, what do you get? U of t minus u of t minus 1.
0 to 1 it will exist.
Yeah, see, in this u of t, it's starting from 0 with an amplitude 1, whereas here it's starting from 1 with an amplitude 1. What is the signal at 0 here? It is 0 only, correct? So 1 minus 0 will be 1. Here at instant, in u of t at an instant 1, you have amplitude 1, whereas here also you have 1. So 1 minus 1 will be 0. So the signal exists from 0 to 1 with an amplitude 1. Got it, everyone? Followed? Are you guys following?
Yes, ma'am.
Now we have to multiply this signal with x of t. I will plot here only x of t. So multiply that with x of t. I will draw x of t here because I have to scroll up again and again. X of t is a signal which is starting from -1 and it is something like this. Okay, this is instant 1, instant 2, amplitude 1, amplitude 2. So multiply these two. This signal u of t minus u of t minus 1. Multiply this with this. What do you get? Second waveform?
0 to 1 it will exist, ma'am.
Yeah. X of t into u of t minus u of t minus 1 would be, what is the overlapping space? If you multiply with x of t, the overlapping space is just from 0 to 1 only, correct? See, after in u of t minus 1, after instant 1, it is 0. 0 multiplied with this is 0. Okay, and here also you have 0 from here for negative values of u of t minus 1. So that 0 multiplied with this waveform is 0 only. So your overlapping space is just from 0 to 1. Okay, with an amplitude 1. Got it, everyone? Followed?
Yes, ma'am.
So till here done. This is our second waveform, which they have told to plot. Okay, what is the third one they are telling us to plot? Third plot. It is x of t into delta t minus 3 by 2. What signal is this?
Impulse, ma'am.
Delta of t minus 3 by 2. So first we'll try to plot this impulse signal. Okay. Then we'll multiply with x of t. So we know that impulse signal will exist only at t is equal to 0 with an amplitude of 1. Correct? Yes or no?
Yes, ma'am.
Impulse, it is a unit impulse function. Okay, it has value only at t is equal to 0. So now you have shifting. So you have t minus 3 by 2. So 3 by 2 is valid on a continuous time scale. So where will your signal be when you shift it? Delta of t minus 3 by 2 means where will the signal exist?
Ma'am, it exists
At
plus
6,
3 by
ma'am.
2. Ma'am.
At
6.
how it will exist at 6? T
1.2,
minus
1.5.
Ma'am,
At 1.5.
it exists at plus
delta
3 by
of
2.
t minus 1.5, right? 3 by 2 means. Delta of t minus 1.5 means where it will exist?
1.5, ma'am.
K is negative, correct? So if K is negative, right shifting. That means the signal will occur at 1.5, t is equal to 1.5, or you can tell the signal is occurring 1.5 seconds late. Got it? Understood?
Yes, ma'am.
Delta of t minus 3 by 2. Everyone understood?
Yes, ma'am.
So multiply this, with x of t. Multiply this with x of t and tell me what you will have. You have x of t into delta times t minus 3 by 2. So where is 1.5? It is in between 1 and 2. What is the amplitude at that 1.5 in x of t?
2, ma'am.
So it is 2, right? So for this waveform, where will this exist? So in third case, I'll get a waveform at t is equal to 1.5 with an amplitude
2.
2. Got it, everyone? I multiply this with this signal. So check what is the amplitude in x of t at 1.5. At 1.5, the amplitude is 2. So 1 into 2 will be 2 at 1.5. Got it?
Yes, ma'am.
Everyone followed?
Yes, ma'am.
Did you follow, guys? Clear? So I have x of t into delta t minus 3 by 2. So this is a impulse signal, okay, unit impulse signal shifted version. So we know that a impulse signal will exist only at t is equal to 0 with an amplitude 1. Okay, it is 0 for all other values of t, correct? So shifted version would be delta of t minus 3 by 2. So k is negative, that means right shift, and the signal is occurring 3 by 2 seconds late, that is 1.5. Okay, it is occurring at 1.5 with an amplitude 1. Now we are multiplying this delta t minus 3 by 2 with x of t. How do you multiply? Check the amplitude at 1.5. Amplitude of x of t at 1.5. You have amplitude 2. So here we have amplitude 1. 1 into 2 would be 2. The impulse signal will exist at t is equal to 1.5 with an amplitude 2. Got it, everyone?
Yes, ma'am.
What is the next case? Next plot.
X of t into u of t minus 1.
X of t into u of t minus 1. So this we know, it is shifted version of u of t.
Scroll up, ma'am. Just a minute.
Yeah. This is your third waveform. Okay.
Yes, ma'am.
Yeah. So we know what is u of t minus 1 from the basics. So we know u of t is a signal which exists from 0 up to infinity with an amplitude 1. Okay, u of t minus 1, from where will the signal exist?
Plus 1.
K is negative, that means right shifting, and the signal is occurring 1 second late. So it starts from 1 and it will go up to infinity. So this is u of t minus 1. Now multiply this with x of t. My x of t is this signal. This is 1 and this is 2. This is amplitude 2, this is amplitude 1. So if you multiply these two, what do you get?
From 1 to 2 it will exist.
At
Yes.
amplitude 2, ma'am.
Yeah, if you multiply any waveform with an amplitude 1, you'll get back the same waveform, correct? So the product depends on the existence of u of t between the limits of t, okay? So u of t minus 1 will exist from 1 to infinity, okay? So whatever is the waveform from 1 to infinity, that we will get back here, okay? So from what is overlapping space for x of t into u of t minus 1? So the overlapping space is after in u of t minus 1, the signal is with amplitude 1 from 1 to infinity. Here the signal, what is overlapping space between these two? As you can see, yeah. So as you can see here, when in u of t minus 1 at 0, the amplitude is 0, and at minus 1 also amplitude is 0. 0 multiplied with that is 0 only. But you have a signal from 1 up to infinity. Here you have a signal at 1 from 1 to 2. So that you'll get back. Okay. After t is equal to 2, you have 0. 0 multiplied with 1 is 0 only. So from 1 to 2, the signal amplitude would be 2. This is the product of x of t and u of t minus 1. Is it clear?
Yes, ma'am.
Others, it is clear, everyone? So this is the fourth waveform which they had asked you. Clear, everyone?
Yes, ma'am.
So as you can see here,
Yes,
later
ma'am.
amplitude is 0. 0 multiplied with anything will be 0. So you'll have a signal only from 1 to 2. Check the overlapping space. Okay. This is multiplication of signals. Got it, everyone? Is it clear? Shall we brief up once again? Whoever didn't understand or whoever has joined late, just have a look here. So you have been given a waveform x of t. This is x of t. Okay. And you have to plot x of t into u of 1 minus t. Okay. X of t into u of t minus u of t minus 1. X of t into delta times t minus 3 by 2. And x of t into u of t minus 1. So first we'll plot x of t into u of 1 minus t. So this is our x of t, we know. They'll not give you u of t. You have to know what is unit step. Okay. They'll just give you x of t, tell you to plot all these. So from the basics, we know that u of 1 minus t, how to plot this, right? First we have to shift it from the precedence rule. First is shifting, then scaling, then time reversal. Here you don't have any scaling, just you have shifting and time reversal. So you are shifting it. How do you shift it? First you will take, you have u of plus 1 minus t. So take u of t plus 1, then take reflection of that to get u of 1 minus t. Okay. So we have taken u of t plus 1, then time reverse that to get u of 1 minus t. So multiply this with x of t. Check the overlapping space, multiply these two. So this u of t minus 1 is existing from minus infinity to 1 with an amplitude of 1. Okay. Whereas x of t is existing from minus 1 to 2. So what is overlapping space? It is only from minus 1 to plus 1. So this is our given waveform, first one. Okay, they've asked you to plot x of t into u of 1 minus t. This is the product of x of t and u of 1 minus t. Second, they've asked you to find x of t into u of t minus u of t minus 1. So you people know how to do this, right? If you subtract u of t minus u of t minus 1, u of t is a signal starting from 0 up and it goes up to t is equal to infinity with amplitude 1 only. And u of t minus 1 is shifted version of u of t. Okay, right shifting. K is negative, right shifting. The signal is occurring 1 second late. So if you subtract these two, check the amplitude here at 0. Here you have 1, here you have 0. 1 minus 0 would be 1. At 1 you have 1 here, here also you have 1. 1 minus 1 would be 0. So this is u of t minus u of t minus 1. Now multiply this with x of t. Check the overlapping space. You have overlapping space only from 0 to 1. So you get a signal from 0 to 1 only. Because to the left of this also you have 0. 0 multiplied with anything is 0. To the right of this also you have 0. 0 multiplied with anything is 0. So overlapping space is just from 0 to 1. Next we have x of t into delta t minus 3 by 2. So this is unit impulse signal. Okay. So impulse signal or unit impulse signal, we know that it will exist only at t is equal to 0 with an amplitude 1. Okay, so what they have given you is delta into delta of t minus 3 by 2. So shifted version of unit impulse. So t minus 3 by 2. K is negative. So right shift or the signal is occurring 3 by 2 seconds late. Okay. So it is at 1.5. So now you have to multiply this with x of t. Where is our x of t? This is our x of t. So check the amplitude. If you have a unit impulse at 1.5 and if you multiply that with x of t, what you have to do is check what is the signal value at 1.5, x of t value at 1.5. So at 1.5, which is the midway between 1 and 2, you have amplitude of 2. So 2 into 1 would be 2 at 1.5. So this is your u of t is a signal from 0 up to infinity with an amplitude 1. U of t minus 1 is a signal starting from 1. K is negative, so right shifting, the signal is occurring 1 second late. Okay, starting from 1 and goes up to infinity. Now multiply this with x of t. If you multiply that, what is the overlapping space? It is only from 1 to 2. See, before that you have 0, 0 multiplied with this is 0. Only from 1 to 2 you have a signal with an amplitude 2. Got it, everyone? Understood?
Yes, ma'am.
So take down next one, next problem. Given x1 of t and x2 of t. So here this problem will involve all the operations. Okay. Given x1 of t and x2 of t, plot. I write x of t here, x1 of t here. So x1 of t is a triangular waveform which is existing from -1 to +1 with an amplitude 1. This is x1 of t. Okay. And x2 of t is a rectangular signal which is existing from -2 to +2 with an amplitude of 1. Okay. This is your x1 of t and x2 of t. So you have to plot x1 of t plus x2 of t, that is addition of signals. Then you have to plot x1 of t into x2 of t, multiplication of signals. Third, you have to plot x1 of t by 2 and you have to subtraction of signals. You have a subtraction, that is x2 of t minus x1 of t. You are subtracting x1 of t from x2 of t. Then you have x2 of 2t. So we have all the operations in this problem. You will get such problems only for your exams. So pay attention. So we have a signal x1 of t which is existing from -1 to +1 and x2 of t existing from -2 to +2 with an amplitude 1. Amplitude is 1 in both the cases, and the existence of t with respect to x1 of t is from -1 to +1, whereas for x2 of t is -2 to +2. So first we will try to plot x1 of t and x2 of t. Okay, so addition of these two signals. Okay, so we'll try to plot that. First one, x1 of t plus x2 of t. I have can see here, the addition of these two signals will result in this waveform. Okay. So first observe, from -2 to -1, what is the waveform? Okay, there is no waveform from -2 to -1 in x1 of t, but there is a waveform from -2 to -1 in x2 of t. So 0 plus 1 would be what is 0 plus 1?
1.
1, correct. To the right side also do the same thing. From 1 to 2 you don't have a waveform here, it is 0, and from 1 to 2 you have amplitude 1. So 0 plus 1 is 1 again. Again from 1 to 2 you have a waveform like this. Okay. Next, check at t is equal to 0. What is the waveform? At t is equal to 0, what is the waveform?
2, ma'am.
2, ma'am.
Amplitude is 1 here also as well. Okay, so 1 plus 1 it is 2. So you will have a signal like this. Similarly to the right side also, you will have amplitude 2. Okay, this is 2 and this is amplitude 1. Got it, everyone?
Yes, ma'am.
It is a similar case on the right side also because it is even signal. These two are even signals, right? Because x of t is equal to x of minus t. Sorry, x1 of t is equal to x1 of minus t, whereas x2 of t is equal to x2 of minus t. These two are even signals. Okay, so you get x1 of t plus x2 of t, something like this. Clear, everyone? Is it clear?
Yes,
If
ma'am.
you want, you can cross verify. Okay. At minus 0.9, what is the signal amplitude? x1 of t, x1 of t, x2 of t. See, in x1 of t, what is the signal amplitude at minus 0.9? T is equal to minus 0.9. What is the amplitude? For x1 of t and x2 of t. At t is equal to 0.9, it will be
0.9 only, right, ma'am?
for this one, it will be 0.1, correct? This is 0. From my signal is extending from -1 to 0. So it is 0.9 here at this point. At this point, 0.9, 0.8, 0.7, 0.6, 0.5, 0.3, 0.2, 0.1, 0. At 0.9, what is the signal? Amplitude. It is 0.1, correct?
Yes, ma'am.
0.1 plus, here you see, what is the signal? At 0.9, t is equal to, sorry, minus 0.9. T is equal to minus 0.9, okay? What is the signal at t is equal to minus 0.9? It is 1. So what is the signal in this waveform at t is equal to minus 0.9?
1.1, ma'am.
1.1. Okay. Similarly, at t is equal to minus 0.8, what is the signal?
1.2.
1.2.
At t is equal to minus 0.8, it is 0.2. In x2 of t, it is 1. So it is 1.2. So at here, you will get 1.2. Okay. Similarly, at t is equal to minus 0.5, in both the cases, it is 0.5 plus 1. It is 1.5. Okay. So it will be somewhere half, 1.5. So at t is equal to 0, what is the signal for both? For this t is equal to 0, what is the signal?
1, ma'am.
1 and 1. So you get 2. At t is equal to 0, you will get 2. Like that, you be adding the point values, you get at t is equal to 0, you will have 1 plus 1, it is 2. Got it, everyone? This is just for cross verification purpose only. Okay, just to show you. Clear?
Yes, ma'am.
So what is the next one? They have asked you x1 of t into x2 of t. You have to multiply. Okay, so multiplication of signals. So this is the first one. And second one is multiplication x1 of t into x2 of t. 1 minute.
Ma'am, we will get x1 of t only, right, ma'am?
Yes, correct. So you have x1 of t multiplied with x2 of t. So when you're multiplying any waveform with an amplitude 1, you'll get back the same waveform. So the existence of this waveform x1 of t and x2 of t will depend on the overlapping space between the two waveforms. What is the overlapping space? For x2 of t it is -2 to +2. For x1 of t it's -1 to +1. So what do you get? From t is equal to -1 to -2, it is 0. 0 into it is 1 here, from -2 to 1. 1 into 0 is 0 only. Here also, from t is equal to 1 to 2, it is amplitude is 1, whereas in x1 of t from 1 to 2, it is 0. So 0 into 1 would be 0. So you get back the same waveform as x1 of t. That is -1 to +1 with an amplitude 1. Got it, everyone? Followed? This is your second waveform which they are asked you. Multiplication of signal. This is addition of two signals. Next, what they are asking you, x1 of t by 2.
Ma'am,
Yes?
can you explain the second one once again?
Yeah. So second one is x1 of t into x2 of t. Multiplication of these two signals. Yes or no?
Yes, ma'am.
So
X1 of t.
what we have to do when we are multiplying, you have to check from where to where the time interval the signals are present. So x1 of t is present from -1 to +1 with an amplitude 1, whereas x2 of t is present from -2 to +2 with an amplitude 1. So this is x2 of t, take this as reference. When you are multiplying any waveform with an amplitude 1, you will get back the same waveform. Okay. So what is x1 of t into x2 of t? It will depend on the overlapping space between these two waveforms. What is the overlapping space between these two? It is from -1 to +1, correct?
Yes, ma'am.
Because at -2 and +2, you don't have any signal here. 0. 0
Yes, ma'am.
into
It's 0, ma'am. So that is why -1 to +1 only.
Yeah, 0 from -2 to -1 you see. Here you see -1 and +1. So -2 to -1 you check. You have 0 here and you have 1 here. 0 into 1 would be 0 only. So we have got 0 here. Again from 1 to 2 you see. Again it is 0 into 1. It is 0. What is the overlapping space? That is this waveform. Got it?
Yes, ma'am. Thank you, ma'am.
So, third one, they have given you x1 of t by 2 to plot. So you have to plot x1 of t by 2. What is this? Scaling.
Scaling, ma'am.
What type of scaling it will result? It is?
Compression. Sorry.
So you're scaling t with the fraction, which is equal to x1 of 0.5 t. So what will happen when you're scaling t with the fraction? The signal will expand, correct? Yes or no?
Yes, ma'am.
So the signal will be present from where to where?
-2 to 2.
You have -1 to +1, x1 of t, correct? So divide that by 0.5 if you feel difficult. So what do you get? You have a signal from -2 to +2 with an amplitude 1. So because you're scaling it by a factor 0.5, you have got an expanded version of the signal. Got it? Understood, everyone? You're following or not?
Yes, ma'am.
Others, you're listening to me what I'm teaching?
Yes, ma'am.
Yes, ma'am.
These
Yes,
are all
ma'am.
important concepts. So I will tell you one more thing. So if you have x1 of 2t, so from where to where will the signal exist? I'm scaling it with the integer. So you do -1 by 2 and +1 by 2. So the signal will exist from
minus 0.5 to 0.5.
0.5. The signal has compressed. Got it? When you scale t with the integer, there will be compression of the signal. When you scale t with the fraction, there will be expansion of the signal. Got it? This they didn't ask, just I have showed you. Okay? Got it, everyone? This is the third waveform which was asked in the question. Understood? Reply yes or no.
Yes,
You
ma'am.
want me to explain any topic still? You're confused? Shall we continue?
Third one.
x1 of t by 2. So x1 of t by 2, this is scaling with respect to t. Okay. So how is t scaled? You have x1 of t by 2. You're scaling t with the fraction, correct? Yes or no?
Yes, ma'am.
You have, what is the scaling factor here?
1 by 2. So we divide the t by
1 by 2. Scaling factor is 1 by 2 or 0.5, correct? So from wherever you have x1 of t, divide the time interval by that scaling factor. Minus 1 by 0.5 is minus 2. 1 by 0.5 is 2. So the signal has expanded. Got it? If you scale t with the fraction, the signal will get expanded. Okay? Suppose if you have x1 of 2t, you will divide this minus 1 and the signal is existing from minus 1 to plus 1. You will divide these time intervals by minus 1 by 2 and 1 by 2. So what do you get? 0.5, correct?
yes, ma'am.
Got it? So this is your x of t, which is from minus 1 to 1. This is your x1 of t. Okay? So my scaling factor is 2. So I'll do by 2. Whatever is the scaling factor, divided by 2. Okay? So the signal will exist from minus 0.5 to plus 0.5. The amplitude will be same. Got it? This is compression and this is
Yes,
expansion.
ma'am.
This they asked you. So I have shown you this. Okay? This is just for your reference. They didn't ask in the question, but just for your reference. So next one is x2 of t minus x1 of t. Subtraction. So we will do that. Yeah, so coming to this subtraction of signals, you have x2 of t minus x1 of t. So how will you subtract these two? If you subtract x1 of t from x2 of t, what do you get? Write the time instance 1, 2, minus 1, minus 2. Okay, so from minus 2 to minus 1, what is the amplitude?
1, ma'am.
Here you have 0, here you have 1. So 1, we have to do x2 of t minus x1 of t. So this is 1 here and 0 here. 1 minus 0 is 1. So the signal will be 1 from minus 2 to minus 1. Similarly, on right hand side also do the same. From here you have, this is left hand side which I am explaining you. From minus 1 to minus 2 you have 1. And here minus 1 to minus 2 you have 0. So 1 minus 0 is 1. Again here you see, right hand side. You have the signal existing from 1 to 2 with an amplitude 1. And here from 1 to 2 you have 0. So 1 minus 0 will be again RHS
1.
1 only. Next, C at t. At t is equal to 0, what do you have?
0, ma'am.
0, ma'am. 1 minus 1,
1
0.
minus 1, it is 0. So the signal will tend to 0. Okay, on left hand side. Even on the right hand side also, it will tend to 0. Got it? Understood?
Yes, ma'am.
So if you want, you can verify this, okay, by doing like this. At t is equal to 0.9, you can you check the amplitude. So at t is equal to 0.9, what is the amplitude? Minus 0.9. in x2 of t? It is 1, correct?
Ma'am, will be time scaled to 1.
What?
-1 to 1. Ma'am, it will be scaled from -1 to 1.
Where it is scaling?
No, ma'am, here the scaling factor is 2, right? So we divide that -2 by 2 and 2 by 2. So the signal will become from -1 to 1, right? With
You're
amplitude.
talking about fifth one.
Yes, ma'am. Oh, okay.
I'm still here only in fourth one. Okay, at t is equal to -0.9 in x2 of t. What is the amplitude? It is 1. Correct? Yes or no?
Yes, ma'am.
Minus in x1 of t, how much is the amplitude? At t is equal to -0.9?
0.1.
0.1. How much will you get? 0.9. At t is equal to -0.9, amplitude is 0.9. Got it? At t is equal to -0.8, how much you have? In x2 of t, it is 1. Minus 0.2, you get 0.8. Okay, it is decreasing here. You can observe, following everyone, what I'm explaining. Are you guys following? So at t is equal to -0.2, what happens? x1 of t is 1, whereas x2 of t is, what is x?
0.8.
It is 0.8, right? x1 of t at 0.2 is 0.8. Minus 0.8, it will be 0.2. So at t is equal to -0.2, the amplitude will be 0.2. Got it? At t is equal to 0, you have 0 again. 1 minus 1, it is 0. Got it, everyone? This is just for verification. Okay, so that is the fourth plot. We'll see the fifth plot, x2 of 2t. So we have x2 of 2t in our question. So x2 of t is existing from -2 to +2. You're scaling it by a factor 2. By 2 you do. So your signal will exist from where to where?
-1 to 1.
-1 to +1 with an amplitude?
-1 to +1 with an amplitude.
We are scaling it with a factor that is 2. If you scale t with an integer, the signal will compress. Okay, if you scale t with a fraction, the signal will expand. So x2 of t is existing from -2 to +2 with an amplitude 1. So if I scale it with a integer 2 and divide this -2 by 2 and +2 by 2. So a signal will exist from -1 to +1. So what has happened? My signal has compressed. Correct? Yes or no?
Yes, ma'am.
So understood, everyone? All operations did you follow? Addition, multiplication, scaling, subtraction. Followed?
Yes, ma'am.
You have any doubts in any operation? Is it clear, guys?
Yes, ma'am.
Yes,
You
ma'am.
have followed?
Yes, ma'am.
Yes, ma'am.
Anyone didn't follow? Any operation you didn't follow? Okay. If you didn't follow, you can ask me, okay? So next problem you take down.
Ma'am,
Yes.
ma'am, this minus 0.9, minus 0.8, ma'am, this is just for our to check the answer, right?
Yes, if this waveform is correct or wrong, just to verify that.
It's not mandatory to write this, right?
No need of writing. Just you can verify that. At x1 of t, x2 of t, at -0.9, what is the waveform? If you add, what do you get? Will this verify? Is this verifying if you add? Or if you subtract that, is it verifying? You can analyze from these two graphs. Okay?
Okay, ma'am.
You're taking the same instant of time from minus 0.9, minus 0.8. So check what is the signal. If you add, you'll get higher value of signals, right? The point values will be greater than 1. If you subtract, it will be less than 1. Okay.
Yes.
So take down next problem. Okay.
Ma'am, homework problem, ma'am.
Yeah. You try this. Okay. I'll solve it in tomorrow's class. You try this. Okay. Given x of n, which is equal to, in this problem, you have been given with x of n, which is specified for different intervals of n. Okay, as you can see. So x of n is equal to minus of n plus 8 for minus 8 less than n less than minus 3. Okay. Then you have 6 for n is equal to minus 3. Sorry, n is equal to 3. I'm sorry, it is for n is equal to 3. No, it's for n is equal to minus 3. Okay, and you have minus 6 for minus 3 less than n less than 0. Okay, and you have the amplitude n between minus 1 less than n less than 7. Okay, and you have 0 otherwise. So there are different, this is x of n, you have to try plotting this. Okay, for different intervals of n, you have been specified what are the amplitudes. So you have to plot y of n, which is equal to 3 times x of n by 2 plus 1. Okay, this is a discrete time signal. As you can see, we have given x of n. So given x of n, so this is a specification for x of n, you have to plot y of n, which is 3 times x of n by 2 plus 1. So how will you solve this? What is the range of n?
minus 8 to 7.
Minus 8 to?
Plus 7.
So what it is given here? It is given as this form. What does this mean? N is greater than minus 8. It is less than minus 3. What is the meaning of that? So this, the amplitude x of n is equal to minus of n plus 8 from n is greater than minus 8 less than minus 3. So from where to where it is minus n plus 8? From minus 7 to minus 4. Got it? First one, it is minus of n plus 8. Substitute the value of n and plot it. Then at n is equal to minus 3, it is minus of n plus 8 from here to here. At n is equal to minus 3, the amplitude is 6 plus 6. Okay. Again, between minus 2 to minus 1, what is the signal? At minus 2 and minus 1, it is minus 6. Okay. Again, you have been given n less than 7. Correct? N is greater than minus 1 less than 7. So what is the meaning of that? From 0 to 6, the waveform is n. Got it? Analyze it and try solving for x of n. Will you do this? Did you understand the problem? Did you understand or what? Here n is less than 7. That means n is 6. And n is greater than minus 1. That is 0. Okay. So this is the values of x of n. So how will you plot this? Will you try or shall I show the plotting?
We'll try, ma'am.
Okay, you try this. If you didn't get, I'll do it. I'll show you tomorrow.
Okay, ma'am.
Okay, if you want me to show now, I'll show. You can plot this. Okay, shall I show you this? Or you will try?
We will try, ma'am.
Okay, so substitute the values of n from -7 to -4, -7 plus 8. At -7, you'll get amplitude -1. Okay, like that, you have to plot it. You try this. Okay, tomorrow, I'll solve it tomorrow. Any doubts you have?
No, ma'am.
Is it clear, whatever we have discussed today?
Yes, ma'am.
What about others?
Yes, ma'am. Yes, ma'am.
Okay, guys, then we can wind up this class. Write your name in the chat box and we can wind up this class.
Thank you, ma'am.
Thank you, students.
Thank you, ma'am.